Course 1 Math, Lesson 20, GCF. As you see, stands for Greatest Common Factor. Have you heard of these before? Not to be confused with LCM. What's LCM? Least Common Multiple. Do you remember what a factor is? Let's rewind a little bit. What's a factor? It's a whole number that divides another whole number without a remainder. With the number 6, we can break that into 2 and 3, right? If I showed 6 with cubes, squares, whatever, I wanted to draw 6 squares. How many rows? 2 rows. 1, 2. How many columns, I guess? How long is each row? 3. 2 and 3 make 6, right? 6 is composite. These are prime, by the way. That's the last lesson. So factors are the numbers that multiply into a product, whereas multiples are not to be confused. In the problem 2 times 3 is 6. What's the multiple? 6. What are the factors? 2 and 3. What are some more factors? How about 4 and 3, creating the multiple of 12? All right, let's keep that all straight. Multiples versus factors. And when we're finding greatest, you're thinking, what's the biggest, what's the highest value? When we're looking for common, we must be looking for something that's the same for more than one. And finally, we've already covered what's a factor. Good. So we're talking, what if they say, what's the greatest common factor of 12 and 16? What's the first step? To find the greatest factor that they both have in common. First, we need to know what are the factors. Let's go in our pattern here. For 12, let's do the first two we know. And then in order for it to be composite, it's going to need more. And it is. We check, does 2 work? Yes. 2 and 6. Does 3 work? Yep, with 4. And now we've met. We can't go any further, can we? So that'd be the answer if the question just said, what are the factors of 12? This would be the answer if it just said, what are the factors of 16? Notice I don't write 4 twice. It multiplies by itself. It's a perfect square. We only write it once. It's only a factor once. So they ask us what's the common factors, first of all. Well, obviously, we've always got 1. We also have 2. Okay, that's now we're in business. How about 3? 4? Yep. 8? 12? 16? 6? I see nothing else in common but 1, 2, and 4. Now, which one's the greatest? We've already covered that they are factors. These are the factors. What's in common and the greatest? Right here, right? The 4 is the biggest of the 3 common factors, so the answer would be 4. Let's look at example 1. Shows 12 and 18. Answer would be 6. They do the same thing we did. And quickly, example 2. GCF, greatest common factor of 6, 9, and 15. So we're using 3 numbers. Factors of 6, factors of 9, factors of 15. First, which ones are in common? Always 1. I see 3 in all 3. Is there 2 in all 3? No, these are odd numbers. No 2. How about 6? Does 6 go into... No. 9? Way too big. Obviously not 15. What about 5? 5 is only for the 15. So As big as we can get is 3. It's the largest number that evenly divides all 3. What's going to always be the GCF of any two prime numbers? And explain. Maybe you've already been thinking this to yourself. But if they're prime, how many factors do they have? Exactly 2. The number and itself and 1, right? The number itself and 1. So in all cases, these aren't going to match unless they're the same number. But what we will be able to say is, okay, that's going to be in common for both. So always 1, I guess, for primes. Let's wrap up. There will be other ways to do this that are going to be important when we get numbers that are too big to do what we just did, where you're listing every possible factor. So don't worry, when we start to get into hundreds and thousands, that we have to list all the factors of 1,000. Thankfully, mathematicians have come up with shorter versions of doing things like that. For now, though, we just need to nail down what a GCF is and use these smaller numbers and the very basic, most time-consuming, work-intensive version of finding them. So let's pick one from this column. Pick one from this column to do. And why don't we try I as well? So 3 in all, please. Thank you.